Hello, in this video we are going to have a look at fork system call. So when we invoke fork in our application, it will create two processes. One is called the child process and another is called the parent process. So the child process is exactly the duplicate of the parent process. So when we call the fork in our application, the process state at that time of the parent will be copied to the child process. So the child process have their own memory space in the kernel, so it will run independently of the parent process. So the parent process have the different PID from the child process, and they can run concurrently onto the CPU as two independent processes. So there are few things that are being reset onto the child process that will have some problem in the child process due to integrity of the parent process. So what are those things? So those things are the signal handlers. So we have some pending signal handlers at the time of fork that is being reset into the child process. Other than that, we have some memory locks, we have the semaphores, we have the timers. These all are being reset into the child process when the context is being copied onto the child process. So as we know, fork is a system call that is provided by the glibc as a wrapper API. So their definition is being in on the kernel side. So if we want to see the definition, we can see the fork.c file on the kernel side. So in there, when we invoke the fork API in our application, it will call the do underscore fork on the kernel side, which in turn call this copy process application API. So that helps in copying the data from one process to another process and also spawning that process onto the CPU. Let's start implementing fork in our application. So first of all, we need to include our header file, that is unistd.h. Then we need to call our fork API that don't contain any argument as such. So we need to print few things above and after this fork. So then we have this main process PID is equal to, then we have percentage %d, then we have to use get PID to get the PID of this process, and after this we are printing the same thing. Then we have after fork PID is, then we need to print in the PID here, then get PID. Okay, so once we compile this, so let's execute. So you see here your main process is 32485 and you have two PIDs. After this fork is being executed, that will be 32485, that is for the parent process that is invoking this fork. So then the second one is for the child process 32486. So let's take one more fork here and see what happens. So if we save this and run again, then we will see we have 4, right? So there we have this parent PID, then we have this child PID, then we have another PID, and then we have this fourth PID. So if you see here, this process have executed this whole main only once, and when we call the fork in here, the first fork will create two processes. So the two processes now will execute the second fork, and it will create two more processes. So if we see here, we'll have four processes from two forks. So that will be 2 raised to power the number of forks. So that is a simple arithmetic for having the total number of calls from the fork. So if we take the 3 forks, then as per our formula, every fork will create 2 processes, and which in turn create total 2 raised to power 3, that is called the 8 processes. So let's save it and execute it one more time. So let's clean it, and then we have to execute it. So if you see here, we have 1 2 3 4 5 6 7, and 8th one is a main process, this one. So if you see here, we have 8 processes that is been invoked from these 3 forks, right? So how to check for these forks? So what are the return types for these forks? So let's clean it once. So we have the 3 return types for this fork. So let's define the variable for the PID underscore T. Then we have the PID. Then we return it from fork. So if PID is equal to 0, then we say we are in child process. So let's print I am in child, and PID is %d, and then we have the same get PID, right? So else if PID is equal to -1, then we say there is some error that is being thrown onto the fork system call. So we'll have some error. Let's have error. Then we have error in fork, right? And else we'll say we are in parent process. So print, so we'll copy the above line. So let's copy it here and just paste it. So I am in parent. Okay, so let's compile it and see what's there. So once we compile it, we only execute the statements which is there in the PID value. Like if you have PID 0, it means it was a child process, and if it is greater than 0, then we'll say it is a parent process. So if we want to print the value of PID into the parent process, so let's print it here also and see what happens. So we have the value is equal to, then we have %d. So let's see what happens now is we'll get the child PID, right? So this is the child PID and we get the value in the parent, right? So, and one thing worth noting here is when we call fork in the main process, so we have the program counter also been copied into the child process. So if you say the program counter is at 10, so the child process will start from the 10th line, and all the state, the previous state of this main function will be copied. Okay, so see you in the next session.